Okay, this is the last example in 7.2, example number 2, and it is just stepping up basically the complexity of the function. Now we have a quadratic inside that absolute value. I'm going to make sure we know how to do this on the calculator. I'm going to do this with the calculator as well, but I really do think pushing algebraically, finding y-intercepts and x-intercepts is a good thing. So we're going to do that first. Very similar to example 2. We just have to remember that when we're finding a y-intercept, we're going to make x equal to 0. Now, I do like function notation. We have to get more and more used to it. The y-intercept is whatever f of 0 is equal to. And f of 0 is putting 0 in for all the x's into our function. So that's negative 0 squared plus 2 times 0 plus 8, all inside of an absolute value. That means the function evaluated at 0 is equal to the absolute value of 8. So f of 0 is 8. Getting used to that function notation, really what this is telling me is that when I put 0 into the x value, I get y, or the output of 8, which means the point on my curve is 0, 8. Right, that's that point. And y-intercepts and x-intercepts are points. Now the x-intercept's a little bit more complex because it's solving for x, but important to start with that consequence, or not consequence, sorry, that concept that for the x-intercept, we are trying to determine the entire function itself is equal to 0. So when is the entire function 0? And this happens when the inside of the absolute value is 0. So f of x is equal to 0 when negative x squared plus 2x plus 8 is equal to 0, which means we have to factor it. The best way to do that is to take out that negative, I think. You treat it as the greatest common factor, and we're left with x squared minus 2x minus 8. We can then factor that bracket to negative 1 times x minus 4 times x plus 2. Kind of skipped a little step there. I'll write it up here. I like to show this t-chart that I'm looking for two numbers that multiply to negative 8 and add to negative 2. Writing out the factors of 8 is the best way to start. We could have negative 1 times 8 or negative 2 times 4, and that's it. But we could move where that negative is. So 1 times negative 8 or 2 times negative 4, and 2 times negative 4 adds to negative 2. And that's why we use the numbers negative 4 and positive 2, respectively. All right, now that's not the end of it. This is just the factored form equal to 0. If you have something in factored form equal to 0, then one of the factors must be 0. So either negative 1 is equal to 0, which can't happen. Negative 1 is a constant. But x minus 4 can be equal to 0. That happens when x is equal to 4. And x plus 2 can be equal to 0, which occurs when x is equal to negative 2. Students are usually pretty comfortable using that or solving those quadratics at this point. If you're not, it's a good idea to go back and maybe do a little more practice in that chapter 3 and 4. All right, to sketch that graph, we are going to use our calculators. And in order to do that, you need your calculator, obviously. I'm going to use the emulator here just because it does show you your key screen. And what I'm going to do is I'm going to go right to the y equals button. And what we need to do is we need to put in the function that we're going to talk about. And really one of the reasons why I want to do this is so that to make sure everybody can find the absolute value button, which is located in the math menu. You have to cursor to the right to num, which is number, and then it's number 1. ABS, it's just, shorthand for absolute value. So we have the absolute value of negative x squared plus 2x plus 8. Now this will graph the actual answer to our question. In order for us to all see the same thing, once we have that function in, I'm going to hit the zoom button and then go down to option number 6, which is zoom standard. Zoom standard is basically going to put that x min, x max, and so on to 10 in every direction. And then we get this graph. All right, now I'm just going to grab a Desmos graph to talk about in the notes because it's a little bit better drawn and I can kind of grab from Desmos easier. All right, I know that can be a little jarring just kind of jumping to that final graph now, but this is the function, the absolute value of negative x squared plus 2x plus 8, and most students kind of default into thinking that what happened here was that there was a section that was going below the x-axis here that's been, reflected above that x-axis by the absolute value, but it is important that it's just as possible, and in fact, it is the case in this question, that we actually had these negative kind of blue arms. that were then reflected above by the absolute value. And I'll show you how to tell that. It's actually quite easy. We're going to jump and use our calculator again. So make sure you didn't have that cleared because we will need to look at it one more time. I just have some kind of critical points marked off there in Desmos so we can talk about that as we talk about domain and range. Domain and range aren't too bad, I don't think, once you have the graph. I know that Desmos doesn't add it, but it's never a bad idea to kind of remind ourselves that this function does continue. You can draw that arrowhead in the upper direction or the upward direction. Now, if we talk about domain and range, again, we see that X is an element to the real. In high school math, there's not a lot of things that restrict our variable. The big ones are dividing by 0, like we saw in chapter 6, or taking the square root of a negative, like we saw in chapter 5. For the range, again, we see that red graph is never negative. It's never below 0. So a very, very common range in this section is that y is greater than or equal to 0, and y is an element to the real. Just forgetting my integral notation there. All right, the piecewise function. And I think it is really important that immediately don't overthink the piecewise function. The way that we break it apart is always the same way. And I'm going to say that f of x is equal to, and I'm going to write the pieces here. So I'm going to take the absolute value function, and whatever's on the inside is going to be in the kind of upper piece. And it doesn't have to be the upper, but it's typical. That's the positive. So it did nothing. The absolute value didn't affect it. But if it was negative, and we'll talk about where that is on the graph, then it's going to multiply my function by a negative. All right, now in both of these cases, we have to find out what restrictions of x make that the absolute value of a positive, what makes it the absolute value of a negative. And the best way of doing that by far is to graph the function without the absolute value. And the way that we can do that is with our calculator. I really love doing it on the calculator because then we can actually see how they're related to each other very, very easily. So I'm going to go back to my y equals, and I'm going to just graph the inside of that absolute value operation. So that's negative x squared plus 2x plus 8. So really just graphing the function if the absolute value wasn't there. When I do graph that, what it shows me is that the original parabola actually is negative when x is kind of outside those x intercepts. Now, I'm going to go put that onto my Desmos graph just so we can take a look at it together. But it's really important that there are some sections, and I'll kind of show you when I draw it onto Desmos, what the original function looked like, and I'll draw it in blue, is it looked like this blue parabola, like that. Now, in some segments or some areas of this graph, they're exactly the same. And I'm going to do this again using my green marker to show the intervals, that in this green interval, from in between the x-intercepts, the function, and I'll write it maybe up here, f of x is equal to the absolute value of f of x. And this happens when we have the absolute value of a positive number. So when the absolute value does nothing is the interval I did in green, and I'm going to write that here. It's when x is greater than or equal to -2, but less than or equal to 4. Now that is that green interval. Here's my -2. I'm everything greater than that. There's my +4, and I'm everything less than that. Because both those things are true, it covers all the numbers in between -2 and 4. Now where the absolute value does affect it, which is the bottom piece, is going to be outside of those x-intercepts. And I'm going to draw that with an open dot, that it is this black interval, and I'll write it right above it, that this is when x is less than -2, and it's also this black interval, when x is greater than 5. It's really important that when you're writing a piecewise function, the pieces have to cover the entire number line. Because unless your original domain was restricted, but that won't happen in any of the 20-1 stuff. So when we talk about the original domain of the function being an element to the real, the combination of the pieces have to be an element to the real as well. And all I'm really saying there is that the black interval plus the green interval has to cover the entire number line. And so my black interval is either x is less than -2 or x is greater than +5. And those two pieces cover the exact same thing as what I have boxed in black up here. So we could either write f of x as an absolute value symbol, or we could write it as these two pieces that I have on the left on the board here. All right, I'm going to put up that full homework assignment, but keep in mind that when we actually do assign it on Google Classroom, we will be looking for a specific question, and I'll have that in the description for this assignment as well. Okay, good luck, and if you have any questions, don't forget to email.